This video is going to cover how to create tokens on the Bitcoin Cash and the eCash blockchains. These are different from tokens in the past in that they have icons and other metadata associated with them that can change over time. In the past, this token icon was a real issue. There was never really a good solution for any of it. And in the meantime, the PSF has created a standard for token icons and metadata that the token owner can change over time. So let me show you what the icons look like. So this is a token on the Bitcoin Cash chain, and you can see this icon. This was generated from Stable Diffusion AI, popular AI algorithm that can generate images. And so this is at token.fullstack.cash if you want to check it out. You can put the token ID here, and it'll pull up data for any token. And this token has an immutable data. Immutable means it cannot change; it's fixed. And mutable means it's changeable; it can change. And so the token icon is listed here, and then there's also this genesis data, which is pretty normal for one of these SLP tokens. So the point here being that the data here in the immutable section is fixed at the time of creation. You can put in as much data here as you want. There's no size limit, but once it's created, it can never be changed again. But the mutable data, anything in here can be changed, and so we put the token icon in here. And here's another example of a token on the eCash blockchain. Again, it has an immutable data, mutable data, and then genesis data. And if you want to dig in a little deeper into the specifications around these token icons, they are published on GitHub under the Permissionless Software Foundation group under specifications. And there's PSO2, which defines the mutable data for tokens. And then there's another spec that's more recent, PSO7, which is schemas for the token data. So this is what defines the shape of the data so that wallets can readily read the token icons and understand how to work with some of the data that's in here. On the Bitcoin Cash chain, I've built this NFT creator. So it's at nft-creator.fullstack.cash. This is the easy way to create a token like this. You can just put in a name, a ticker symbol, and paste in a URL for an image, hit create token. It takes about 15 to 30 minutes, and it costs about 10 cents in Bitcoin Cash, and it will generate a token just like this with all the steps that I'm going to show today. Today I'm going to show how to manually create a token. So the NFT Creator app does not yet exist on the eCash blockchain. And even if it, say, went down or something, it's good to know how to do it manually. And so that I wanted to cover that in a video for other people. So I'm going to be using the eCash blockchain for this, but the steps are exactly the same for Bitcoin Cash. So if you want to follow along, if you're on the Bitcoin Cash chain, you would want to use the psf-bch-wallet. This is a command line wallet that I'm going to be using today to generate a token. And for the eCash blockchain, there is the psf-ecash-wallet. So they're both pretty similar. In fact, they're identical in terms of usage. It's just one is for the Bitcoin Cash chain, one is for the eCash chain. So let me give an overview of what we're going to do. So we're going to create a token with icons and other metadata. And as I mentioned, there is the NFT creator on the Bitcoin Cash chain, but today we're going to be doing it manually. There's a series of steps. I think there's 10 steps, and so we're going to go through each of those. And at the end of it, we will end up with a token like this in our eCash wallet. So let's get started. So 10 steps is quite a few. This will get pretty complex pretty quick, but and that's the value of the NFT Creator app, is that it does all this for you, so you don't have to think about it. But for the engineers out there, it's always good to know what's going on under the hood. So this is what's going on under the hood with that app. So to start with, you need a token icon. I gave Stable Diffusion a prompt of a bridge to nowhere, and this is what it generated. An image of a bridge going into a black hole, apparently. So I'm going to be using this as my token icon, and I've already uploaded it to web3.storage. Web3.storage is part of Filecoin, and it's a way to upload images to the Filecoin blockchain. You don't have to use it, but I highly recommend it. There's also NFT.storage. It's basically the same thing, but really all you need is an image with a URL. So once you have that, that's step one. You just need an image with a URL, and then I'm going to pin the icon. So let's see. Need to find. Okay, so here I am in psf-ecash-wallet, and as an intro, so to set up psf-ecash-wallet, you'd want to clone this repository. So it's on GitHub, Permissionless Software Foundation, psf-ecash-wallet, and there are videos. I guess not here. I guess what you'd want to look at is the psf-bch-wallet. I need to move these links to the videos to the README. But I have a video here on how to install it and how to configure it, so I'm not going to cover that in this video. I'm going to assume that you've already watched those. But to familiarize yourself with all the available commands, you run bin run, and then you can issue a command. So I issued the help command, and that lists all the other commands that are available. So the first thing to do is to pin the icon to our IPFS cluster with the p2wdb pin command. So this is leveraging the pay-to-write database. That's what p2wdb is. So first you're going to need a wallet with a little bit of eCash in it. And if you're doing this on the Bitcoin Cash chain, same thing applies. So a wallet with a little bit of Bitcoin Cash in it. So I currently have this test wallet with 466 eCash in it. And I'll be using that. So I want to issue the pin command. And so there's two arguments. There's the name of the wallet that's going to pay for the pinning, which is test01 for me, and then the CID that I want to pin. So if I go to the image, this string of characters that starts with BAFI, this is the CID, or content ID. This is how content is located in the IPFS network. So I can paste that in here. And this is going to take a minute, but what it's doing is it's reaching out to the pay-to-write database and the pinning cluster that runs on top of the pay-to-write database, and it's asking it. It's paying for the pinning of this icon. So here's some of the output. Essentially, what happened is it paid some eCash in order to pin it, and this is the entry that I got back, and I can actually click on that and look at it. So this is the entry in the pay-to-write database, and oh yeah, and so I already knew what the CID was, so that's the pinned icon. So that's step one. We've got the icon on Filecoin, and now we've got it pinned to IPFS as well, just as an extra step. And now we need to create the immutable data and the mutable data. So I have a template here. This is from a previous token that I created, and this schema comes from that PS7 specification that I called out. And so I need to update this template. I'm essentially just copying. This is from another token. So first of all, I need a timestamp for the immutable data. And so if I go new date, so I'm using JavaScript, and I'm assuming that people watching this are familiar with JavaScript. So I just generated a timestamp in the ISO format, and it's always good to have a timestamp there. And this is actually part of that PS7 spec. So I'm going to call this, it is Dolly computer generated art, and the prompt was a bridge to nowhere. That was the prompt I used. I'm going to leave the rest of this information alone. If you want more information on what each of these line items are, again, check out the PS7 token data schema specification. And so this is in expanded JSON and format, and so I need to stringify it. And so I can go JSON stringify, and now I've got a nice string of JSON. I'm just going to paste that in here. Okay, so now that I have my JSON stringified, I can pin it using this JSON command. So what that's going to do is it's going to upload the JSON to the pay-to-write database, and then pin that JSON with the IPFS cluster so that the JSON is available over IPFS, and it's going to give me back a CID, which is what we'll use when we create the token to reference this data. So let's look at the help for that command. So we're going to give it the name of a wallet to pay for the transaction, and give it a string of JSON, which we just generated. And notice that it's wrapped in a single quote. That's important. And so now I'll let this go, and again, this will take a minute or two because it's a multi-step process where it's going to upload the JSON and then issue another command to pin that JSON, and then finally it'll be able to return the CID that we'll be able to use in our token data. Okay, so we've got that came back, and we have this CID now that represents, let's see, yeah, that represents the immutable data. So we're just gonna stash that right here for now, and we'll come back and use that later. And in fact, if we want to just see what that data looks like, this is the IPFS gateway for the eCash version of the pay-to-write database. And so there's the JSON data that we just uploaded being retrieved from an IPFS gateway. Okay, so that was steps 3 and steps 4. So now we're going to do the same thing, steps 5 and 6, for the mutable data. So again, here's the template. I'm going to update this, and the token icon is here, so I'm going to copy that URL into the token icon section, and I'm going to update this. All this data, if you get this wrong, it's not such a big deal because you can update it later. It's the mutable data that you really want to make sure you have that right, because you can't change that later. A bridge to nowhere. And this is a simple NFT, which means it is actually technically a fungible token, but it's going to have no minting baton, decimals of 0, and a quantity of 1, which makes it an NFT because there's only one of them, and it's non-divisible. So that's what we call a simple NFT, as opposed to the more formal NFT specification. So I'm going to leave the rest of this alone. Again, if you want to know what each line item is, it's in the PS7 specification. So just like I did before, I'm going to copy that JSON and I'm going to stringify it. So there is our stringified JSON. And again, I can issue that exact same command, and I'll just replace the immutable JSON with the mutable JSON. There we go. Okay, just like before, I got a CID as the output. So this is for the mutable data. So I'll paste that here and we'll set that aside. Okay, that was step 6. So now what we need to do is create a new wallet or key pair for controlling the mutable data. So this is the way the mutable data works, or that for the token icons and the other metadata, is that it's a separate key that's controlling it. So even though the token can move around and be sold on an exchange and change hands, the data controlling the mutable data, or the key controlling the mutable data in that token is separate from that. And so the way this works, or the intent behind this scheme, is that this allows artists to enforce royalties. So for example, if I sold this NFT I'm about to create on the DEX and someone bought it, they would probably want their ownership reflected, and so they would come to me as the artist, and I would retain the key that updates the mutable data, and I would update that to reflect that they are the owner. And then if they then sell it on the market again, and that art has say a license saying that you need to give me as the artist like 10% of any secondary sale, this is my leverage. So the new owner is going to want their name reflected in the mutable data as the new owner, so they would have to come to me, the original artist, in order to have that done. And so that's one use case. Another use case is that a company, say, could create many NFTs and control all of them with this one single key pair, and so that's highly convenient, especially for fungible, but also for NFTs. So a few different use cases there, but that's the general scheme. So I'm going to create a new wallet, and let's call this token 2 MDA. So MDA stands for mutable data address. You're going to see that a few times, and I'll get the address for that. Wallet address. Again, if you want to know, I know what commands I'm using, but if you want more information, you can do bin run help, and then or do the command and then -- help to get the detailed help for that command. So I just created the wallet, and I'm getting the address for that wallet, and now I'm going to fund that wallet using my eCash web wallet. I'm just going to send it 3 cents worth of eCash, just so it has enough to make. I think I just need to make one transaction, really. So while that's going through, all I really needed is the address. And so step 7's done, and so we're going to generate an MDA transaction ID using the token MDA TX command. So what this does is it generates a transaction that goes into the document hash field of the token when we create it, and that's what links the token to the mutable data address. And then that mutable data address, like I said, controls the mutable data. It's the only anyone with that private key has the ability to update the mutable data by creating a new transaction and pointing to the new data. So let's see, we're going to use the token mdatx command. So let's look at the help for that. So it just has 2 arguments. So I'm going to pay for this with the test01 wallet, and the address is this one here for the MDA wallet that we just created. Yeah, it's because some of the eCash stuff is still a little clunky, so that's just its way of telling us it wants the Bitcoin Cash version of the address. And this is probably a good time to point out, if you need to work with addresses between blockchains, you can go to this address.fullstack.cache. And it's a simple little web app that you can give it any type of address format, and it'll convert it into all the other different types of address formats. So for example, if I give it a Bitcoin Cash address, it'll show it in simple ledger format and eCash format and legacy format. Okay, so that worked. We initialized the mutable data address, and we have this transaction ID now. So let's set this aside, because this is what will link the mutable data to the token. So that was step 8. Okay, now step 9, we need to point the mutable data to the CID from step 6, which is our mutable, when we created the mutable data, using the token update command. So bin run token update. Let's look at the help for that. So that has 2 commands, and now this must use the mutable data address, because any address other than the MDA that tries to update the data, that could be malicious, so it gets ignored. The specification only follows updates that originate from the MDA address. So let's see, what was that wallet that I created? Token 2 MDA. And the CID is going to be the CID of the mutable data right here that we created earlier in step 6. So this is the command that's linking the mutable data to the token. And if I wanted to update the mutable data, this is the command that I would use to update it. I would generate some new data, upload it to IPFS and get a CID, and then I would issue this command with the new CID, and that would update the pointer to point to the new mutable data. Okay, so that's done. So finally now we have all the pieces to create the token. So there's actually several token creation commands. So we're going to use the fungible command, because we're doing a simple NFT, so it's just a fungible token of quantity 1 and no decimals and no minting baton. And but there's commands for creating group tokens and formal NFTs. So let's look at the help for this. So these are all the arguments that we need to give it, and yeah, okay. So I've got the command here from a previous token that I created. So I'm going to use the test01 wallet to pay for this, and I'm not going to include the -b because I do not want a minting baton for this. And the hash, or the document hash, is this transaction ID that we got. That's what links the mutable data to the token. And we're going to give it a name with the -m. This is going to be a bridge to nowhere. We're going to use the -q of quantity 1, so we're only creating one token since this is going to be an NFT. The -t is the ticker, and so I'm just going to give it a ticker symbol of NFT. And -u is the URL or document URL. This is the CID of the immutable data. So we're going to grab this CID that we got from before. I think that was step 4 maybe. And the IPFS prefix is important. Don't forget to have that. So these are all the arguments that we're going to need. And I went through that pretty fast, but if you just read through these arguments in the help, it'll make sense. All right, so let's give that a go. So this is the actual, so now we're actually creating the SLP token. All right, so the token's created. Here is our token ID. I'm just going to save that. And now if we go to the token explorer at etoken.fullstack.cache, we can paste in the token ID and see if we did everything right. All right, there's our token icon. That came up. That's great. And it was able to detect the immutable and mutable data. Bridge to nowhere, bridge to nowhere. So here's all the data. So it looks like we created the token successfully. And now we can send it to a web wallet like ecash-wallet.fullstack.cache, and the token will show up with the token icon. And if you go to dex.fullstack.cache, you can sell this NFT on the DEX.